let's move to the new board or the next board where I will be talking about .1x authentication and different methods, right? So in the last class, I have showcased a little bit things, some of the things to you, right? But we were not able to visualize them, right? And I would like to maybe go ahead with the discussion, whatever from where we left in the last class. So as you all know, we have this guy, Mr. Rahul, here with his laptop, right? And you all know that now I know this entity with a name which is Supplicant, right? This guy is actually my authenticator and this guy is authentication server. So you try to understand that between now these guys, we have enterprise network, and you should have this understanding that ISE can be in one location, right? Which can be really kilometers apart from the actual client. Okay, so complete enterprise network could be between the endpoint, which we want to authenticate, and authentication server, right? So what is happening when this guy connects to this switch 0/1 port, and I am showcasing you that port right here. This is the 0/1 port of the switch. So what I'm doing right now is I have gone to 0/1 port of the switch and I have configured some commands, maybe 3 or 4. Don't worry, I will be talking about them, but not today. So these configuration commands are specifically to enable 802.1x authentication or .1x authentication on this switch. Once you do that, believe me, this port is up, although maybe this port was up previously also, but once you do that, this port is up, but it won't be letting much traffic to pass through it. If you send DHCP traffic, by any means, it is not going to pass it, right? Through this port, HTTP, HTTPS, TFTP, nothing. No traffic can pass to this port, right? It means that when you come up with the laptop, even the DHCP discover message cannot go out and cannot pass this port 0/1 port, right? And that is why this guy will never get the IP address. If that is the case, then why we have done this .1x configuration? We have done this .1x configuration so that whoever connects on this 0/1 port, I really want to authenticate him, right? And that is why I'm only allowing EPOL messages. We have discussed about it, that there were 4 types of such messages, right? Request, response, then success and failure, right? Interesting. Now, you all know about this thing too, that these EAP messages, when reaches to switch, right? There is another protocol which is working between the switch and the authentication server. The name of the protocol is Radius. And now you all know that between these switch and the identity services engine, your entire IP network or TCP IP network is up and running, right? So I understand that we need a new protocol, EPOL, so that we can send the message, right, between a client and the switch, because we didn't have the IP, but here we have the IP. So whatever the messages we have, right, radius messages, right, we are sending it over IP. But why radius? Because radius is a protocol which works between the switch and the identity services engine. And believe me, this radius protocol is capable of sending some great information. Sorry for the spelling mistake. This is radius, right? Remote access dial in user service. So this radius protocol is actually working between works between this authenticator and the authentication server, right? So what exactly it is doing? So whatever the messages you are sending, the EAP messages, once they reaches to the switch over EPOL, I will be talking. I will showcase you this, right? These EAP messages are going to be carried in radius protocol. ISE understand radius. This switch understand radius. That is why whatever you are sending, it is going to be opened by this ISE and it can get it, right? And the interesting thing is that there are 4 or 5 messages which we are going to study in the radius message. One message is radius success or radius accept message, I believe, right? Not success. This accept message is as good as, means once the switch receives the success message or the accept message from the radius, it knows that the EAP authentication is successful. Do not worry about it, about the message. But I want to say that this radius protocol is very, very important for 2 purposes. One is authentication and the other one is authorization. Means once Rahul authenticates, how this authentication is going to happen, I will be talking about it. Don't worry. There are different methods, EPLS, EPEEP, and so many methods are there. We will be talking about in detail. Suppose the authentication is done. If the authentication is done, just try to understand that suppose we have a big building with several rooms and it has a big gate here. I am on the door and the guard asks ID for me, right? It is as good as that our guard wants to authenticate me. I showed him the ID and he let me into this building. But once I'm into this building and every room is locked, then there is no point of reaching to this building, right? The second point after the authentication, or the second major thing after the authentication, is authorization. And that is why this identity services engine is AAA, right? Authentication, then authorization. So this radius protocol has the capability to send information to this device. Which device? This switch. Once radius server or the identity services engine knows that the Rahul is Rahul, he has been authenticated onto this network. It is the responsibility of the ISE server to configure something here, that this guy should be part of which VLAN, right? What access I should give to this guy. And that is also dictated by this identity services engine in accordance to your policies using radius. I will be showcasing you those values also, what values comes, and we call them attribute value pair. We will be talking about in detail. Maybe once we are configuring these authorization policies. Attribute means that I want to send a VLAN number, VLAN, and the value is maybe VLAN 10. This is my attribute, this is my actual value. Interesting, right? So try to understand two pieces: ePOL between the supplicant and the authenticator, and radius between the authenticator and the authentication server. At the end of the day, your EP messages will be flowing from the client to switch port, and from that switch port or that switch to identity services engine over the radius protocol. Now let's try to visualize these messages, right? And I am a big fan of visualization, because if you can visualize, you can understand it well. So just try to understand. If I talk about ePOL, what exactly ePOL, right? It is to send EP messages at the over the LAN, right? The LAN is between this guy and this guy. This is a small segment of the LAN, right? Maybe this port is 0/1. So suppose this guy wants to send a simple message in which it is sending its identity. Identity is Rahul, and this message is EP message, right? How I'm going to send it? Now I am talking everything in terms of 802.1x. In my previous class, I had just given you the introduction of all these things, right? Introduction about these messages, right? But now I am specifically talking EP with respect to .1x authentication. So something, right? Something can deviate from my previous class, only little, right? Because previously I was only talking EP. Now I am talking .1x authentication and EP together, right? So what is happening, guys? I need to send this message M, and that is why I have drawn this message in this bigger drawing so that you can visualize. Here is my EP message in yellow color. Maybe I have written Rahul inside it, which is my identity. And by the way, such kind of message is known as EP identity messages, right? These are also your EP response messages. Interesting, right? But at the end of the day, I want to forward this message to this switch so that it can identify, so that it can open it and it can understand what is written inside the EP message. The whole sole purpose of this ePOL is to send this message from client towards the switch. As simple as that, right? Now, we all know the .1x protocol is working here, right? So what is happening is I am encapsulating this message into the .1x protocol, or I can say I have a little letter I want to send. So I have taken an envelope, bigger envelope. The name of that envelope is .1x, and I have put that envelope in. I have put the EP envelope inside the .1x envelope. This EP envelope, or sorry, the .1x envelope is going to have parameters of .1x, which is going to be understood, which this switch is going to understand, right? But at the end of the day, whatever the red envelope I have, this is my message, which I want to deliver, right? Although this message contains a EP message inside it, which is going to be understood by the switch, right? And that is where I am again putting this red envelope into a bigger envelope, and the name of that envelope is L2 header, and that is where source address and destination address come into picture. Source address is going to be the address or the MAC address of this guy, and destination address is the multicast address where we are listening ePOL messages. And in the last class, I mentioned this address is MMM, which is not the correct address, by the way. You can have a look at it. What is the destination multicast address for EP messages? Right? Interesting. So if we have encapsulated this message into the green message, which is my Ethernet header, I can definitely send it over here. And of course, one more thing. People ask that, Mr. Vishnu, why only header? Layer 2 has trailer also. I understand that you are really, you really understand layer 2. But that is there for sure. If I put the header, trailer value is also be there. But I do not want to showcase you that, because I want, if you understand this, then you can visualize the entire packet. Generally, how we make this packet, we are going to say this is my EP message, right? And then after EP message, I have .1x, and then I have layer 2 header, right? This is the generally how we show packets, right? But this is another way, because in Wireshark, if you want to really understand, you are going to see the messages like this. Now let's talk about what is going to happen at the switch. Once this message, the green color message is received at the switch, switch is going to see what? It is going to see only the green message, right? The green, the bigger envelope. It is going to check what is the destination MAC address, and the destination MAC address is MMM, which is the MAC address of this switch. It doesn't mean that it is going to send it to everywhere, because the switch itself is listening on MMM. So the message will be delivered to the switch. Switch will be processing it. It is going to open the green color message, green envelope, and it is going to take out that .1x message. It is going to check the .1x parameter, and eventually it knows that there is something inside it also, right? It will be seeing that there is a yellow color message inside .1x, and it is going to find, this is the EP message, which is the identity message, which is having some information given by the client, maybe the Rahul, right? The username. And now this is the duty of this switch to send this to authentication server. Why? Because you have configured here that the EP messages or the .1x messages should be delivered to this identity service engine. That is why you are going to configure and configure the IP address. And then you also have to configure one more line in which you have to specify port. Why port? I will be talking about it, but it is the responsibility of this switch to send this EP message to this guy. But how switch is going to send it, right? Switch knows that me and server understand identity services engine, right? Sorry, me and authentication server understand radius protocol. So he's going to encapsulate this message into the radius protocol and send it. And then I would like to showcase you this encapsulated message right here. At the end, you all know, right? This message, this is my duty to send this message from the switch to authentication server. I'm going to encapsulate this message, or I'm going to put this message inside another envelope, which is my radius message. As simple as that. And then this protocol, this radius protocol, use UDP protocol to send this message, right? Because now we have entire TCP/IP infrastructure, right? So somewhere at the application layer, radius protocol is working. It is creating its message, which is the EP message, right? Which it goes from the switch, and it is encapsulated into the radius. This is generated by the application, which is radius. It is going to be delivered to the transport layer, which is having TCP and UDP. So basically, radius has decided to send its messages over UDP, and that is why you see the UDP. The source port of this message is going to be 1646. The destination port is going to be 1813. That is why you need to configure. When you configure radius between this switch and this server, you need to configure these two things, right? Source port and destination port. And of course, if you want to send it, you are going to use the source IP and destination IP. Destination IP is going to be the IP address of the switch, which may be XXXX, and the source IP is going to be the interface of the switch. Maybe it's a VLAN interface, maybe the layer 3 interface, whatever, right? Which has the reachability to this identity services engine. And this is how you are going to visualize the radius message. But now my duty is to let you know about the messages which actually flows at ePOL and radius, right? So the ePOL messages are only these much: start, request, response, success, failure. And you must be thinking, Mr. Vishnu, You didn't talk about start message to begin with, right, in the last class, and that is where I'm saying there are going to be a little bit deviation from the previous class, because previous class I was talking about only if. Now I'm talking about .1x, 802.1x authentication and how it behaves in that, right? And then if I talk about radius, radius is also similar messages, right? And they here, believe me, we do not have acknowledgements, right? If I am sending a message, and if the for example, if I am sending a request, I am getting a challenge. In case of radius, believe me, it proves that my request message has been reached. My request message has been reached to ISE. As simple as that. So if I talk about radius messages, we have access request, access challenge, access accept, access reject. Request and challenge are as good as your request and response messages here. For example, if I'm sending my EAP response message, it will be going into, for example, whatever the message comes to the switch, it will be going towards identity services engine in the access request form, right? Why? Because the switch is saying somebody is there, some client is there, and he wants access. Let's authenticate it. And here are some of the details of this, right? This guy. And then this guy can say, I want to challenge it with some protocol. Maybe I want to authenticate it with username, password, with certificates, with so many other things, right? And once the authentication is done, ICE will be sending the accept message. The meaning is I am convinced I have authenticated it. And if it is sending the accept message, it means that switch understood this authentication is successful. So it can send here EAP success message that the authentication is successful. And that is how the communication is happening. Because at the end of the day, just remember the communication or the authentication is happening between this guy and this guy. This guy is just passing through the traffic. Do not worry about it. I will be showcasing you exact step by step how this communication will be happening. So in the next board, just have a look at it. What we have here, I am explaining you the message flow of this .1x authentication. We have here Mr. Rahul, which is the supplicant, or supplicant means the application which is running on his laptop is the supplicant. We have here Authenticator, and we have here Authentication Server. These are the three entities which are working in .1x authentication. Now I'm going to explain you EAP from the .1x perspective, right? So here, once everything comes up, when you connect this port of this laptop, and I am explaining you the wired authentication. First thing first, .1x wired authentication. So I've connected it to 0/1 port. As soon as I connect, this supplements come up, and it starts sending EPOL messages. And the first message which it sends is a start message. How it is reaching it is the same thing. Means I have this EAP message, right? And I'm sending with my source MAC address, and the destination MAC address is the switch multicast address. It will be reaching here. Of course, switch is going to open it. It is going to open the EAP. In the previous class, I mentioned that this EAP start message will be sending toward the authentication server. No, that is not the correct in the .1x terminology, right? This message will be replied to this guy only. Which guy? Switch, right? Because this guy wants to start the communication. At the end of the day, you all know authentication server is going to ask only one thing, right? Give me your identity. And that is why this, instead of sending this message to authentication server, this guy is replying, I am requesting your identity. Give me your identity first. Identity doesn't mean the password, believe me. Identity means your username. That is it. Once this guy receive EPOL request message, right, which is a type of a message which is known as identity, it understands, because this understand EAP message, right? It is going to say, it means that my start message reached somewhere because I got identity message, right? Interesting, right? So once it gets the identity message, it is going to send the response, EPOL response, in which it is going to say, I am Rahul. Maybe it's username. Somebody in the Hindi class asked that maybe this guy is not logged in into this, then who is going to send? This machine is going to send, because the username is going to be saved in this machine's database. I do not know what to call this database of Windows machine or maybe Mac machines, but we can send the username right from there. And then once the identity message reach here, it is going to be EAP message, EAP identity message. The switch is going to open it. Just try to understand, it is opening the message by opening the Ethernet header, then the .1x, and then it is going to find this. And now switch knows it needs to send this message to authentication server because it doesn't know what to do with the identity, right? because this is only Authenticator. It needs somebody. I'm not saying that you cannot put all the functionality on this switch of Authentication Server. If you can do that, then this guy can reply. But try to think your switch is doing everything, whatever ICE is doing. It is going to be a problem, right? Switch is not the switch then, right? So you will be having this EAP message right there onto this switch, and then switch is encapsulating these EAP messages into radius messages, right? And this radius message will be of type access request. Switch will say to Authentication Server, there is somebody with the identity Rahul. He want to uh, join the network. Can you authenticate it, please? And that is why it is an access request. And here is the thing, once this message reaches to Authentication Server, it is going to be open the radius message. Inside the radius message, it is going to find EAP. Inside the EAP, it is going to find the radius, sorry, Mr. Rahul username, the identity. And you all know this guy is actually connected to Active Directory. It can go and check whether Rahul is somebody with the name Rahul is there or not. I'm not saying this is the actual authentication. I'm just saying it is just matching into the Active Directory whether Rahul is there or not. And Active Directory is going to say, yes, Rahul is there. And on the basis of that, this can decide how to authenticate this guy. You must be wondering, Mr. Vishnu, didn't you just authenticate? Dude, anybody can send the username of Rahul, right? I cannot identify or authenticate this guy on the basis of username, but on the basis of the username, right? I can define something here which is known as policy also. Do not worry about the word policy. It is going to be very easy once we understand it. Don't worry, right? I can define something on this ISE that if somebody from the wired portion come, I want to authenticate it using username and password. Really, really interesting. You can define this. Or I want to identify him using a certificate. I want to identify him using something else, right? And this you need to define on the identity services engine with what you need to authenticate, because at the end of the day, .1x authentication is what. Do not forget the basic idea. If somebody comes to my organization, I need to authenticate it. Who are you, right? If you are part of my organization, then you can join the network, and then maybe I can give you some access, right? Or the complete access. So at this point, when the request with the identity comes, this identity services engine is defining what to do next, how to authenticate the client. And that is why there are different mechanisms. One mechanism is maybe EAP PEEP. The other mechanism is EAP maybe TTLS. Other mechanism is EAP TLS. These are just the way how you are going to authenticate. That is it. And there are more than maybe 20-25 such methods you can use, you can define in in your identity services engine. By the way, I am just taking the name right now. We do not know about it, but believe me, in the next boards, I will be explaining each and every method, right? But I just want to tell you, once the identity information reaches to Mr. Identity Services Engine, it is just going to say, yes, I know that this guy is there in the AD, but still I want to authenticate him, right? Because username can be sent by anybody, right? And that is why he's going to select a method. That is why it is going to select a way how to authenticate it. And those way names are EPEEP, EPLS, EP, how it is different, what exactly they are doing. Believe me, you are going to understand it because you understand TLS now. If you understand TLS now, all these methods are going to be so easy for you. Don't worry about it, right? So now this guy decides, suppose this guy decides the method number one, I'm just calling it method number one, right? Which is EAP TLS. So ICE is going to send a radius message back to the client, so not to the client, to the authenticator or the switch, that I agree. This guy is there in the AD. This guy is there in the identity store, but I want to verify it with the method, with the authentication method, whose name is PEEP. The switch is going to open this message, right? And what he's going to do, I am going to explain you in the next page, right here. So the till fifth message, we had discussed it, right? Now, once that once the challenge message come here, inside the challenge message, right? There was a method specified which is EAP PEEP we want to do. And this is signed by the site. And do not worry about it if you do not understand what is EPIP. This is just the name. For me, it is just the name, right? Now we are sending, now the switch is opening the radius message. It is going to find this EAP message and it's going to send this EAP message, right? We have only response and request message here. So previously the response had come and now I'm sending the request. And this message, previous message type by identity message, this message type is authentication because we are sending some authentication information and we are sending in this message that the server wants to do EAP, PEEP, right? This is just the name for us. Interesting. Now, once this message reaches here, this client understand that this is a EAP message, EAP auth message. It is going to open it and it is going to find that the server wants to do EAP TLS with me. And if the supplicant or this device application support this method, it is going to say, yes, I want to do it. It is going to send the response message with auth and it is going to say, I want to do EAP PEEP with you. Switch is going to receive this message, it is going to send it to the authentication server. In the access request message, it is going to say, yes, the client is agreed, right? See why we are doing this much pain. One, the message comes here and then message goes here. You all should understand this by now. This client machine doesn't have any IP address. First, the message has to come to the switch, then switch has to encapsulate into the radius and send it to this guy ISE, right? So now access request is here. Inside the access request, what do we have? We have that client is ready for doing EAP PEEP. As simple as that. The message will reach here. Identity services engine will be opening it. And at this number 8 or the step 8, you all should agree with me that these two guys, client and server, authentication server, agrees on one point, that they want to authenticate each other with EAP PEEP. See, the 8 messages, whatever we have showcased you, right? Or I have showcased you, have gone into this agreement itself. They want to agree on a particular thing, particular method, how they are going to authenticate each other. Now the whole sole point is how EPEEP works, right? And then the message will be exchanged on the basis of this protocol, because this protocol can be only username and password based. This protocol could be EAP TLS, could be anything else, right? Now the other messages, whatever I have written here, there are going to be the multiple messages based on authentication negotiated. For example, if it is EPEEP, EPEEP messages are going to follow, but the whole sole funda is same, right? Right? The whole sole thing was that if I'm sending a message from here to here, ePOL is going to carry it. If I'm sending a message from here to here, Radius is going to carry it, right? So now the question is, let's talk about first thing first regarding this EPEEP. What are the message all which are going to flow after the step number 8? But before that, just have a break. Just think in your mind that we have spent time till this 8 steps, right? To just understand one thing, that ISE and the client agrees on one method, right? That they want to do authentication with EPEEP, right? Now, let's try to understand what EPEEP is. So, first thing first, EPEEP should be understood by this supplicant as well as this identity services engine. And if they have negotiated it, they both know about it, right? In EPEEP, what happens? Client is going to authenticate server using certificate, and server is going to authenticate client using username and password. And you must be thinking, Mr. Vishnu, what? You don't get it. So I would like to explain you this in detail, right? So now we are done with the initial 8 steps of the message exchange, where we noticed that the common protocol is, the common authentication method is EAP PEEP, and now we are talking about how it is going to happen. So as I mentioned, in EPEEP, you have to, a client has to verify server has to verify client, right? Client has to verify server on the basis of certificate. And this is really, really easy. How you are going to do that? You remember your TLS protocol between Anjali's laptop and HDFC? First thing first, what was happening there? You were sending hello. Server was sending hello, right? And then server was sending a certificate. You were verifying it. And that is how you were verifying the server's authenticity. Try to remember at later stage in this process only, you need to verify the client also. Means client is going to send the username and password, and he can't send it in the clear text. So we are going to use this tunnel, because we know once the TLS connection form, whatever goes inside it, it is highly encrypted. Nobody can, right? So try to understand what we are using, right? So what is going to happen? Once the access request be here, both clients and server negotiated EPEEP. The first message, this first message will be going from here to here, which is going to be hello. That is exactly the same message in TLS, believe me. Interesting. And you must be thinking, Mr. Vishnu, how this message can flow here? Because between Anjali's laptop and HDFC Bank, we were sending these messages over TCP. Where is TCP here? So believe me, guys, there is not a requirement that TCP should always be there. TCP is just working as a transport protocol. It is taking the hello message of the TLS protocol from Anjali's laptop to HDFC Bank, as simple as that. And here, if we do not have TCP, that is fine, but we have ePOL, right? ePOL is going to take this message, hello message from here to here in its own messages, like the request messages, right? You all know. And from here to here, it is going to be taken by radius. At the end of the day, the whole sole point is I need to send this hello from the source to destination. That is it. Doesn't matter who is taking it, whether it's TCP IP or whether it's ePOL and radius. People get a lot of confusion in here at how the TLS connection is formed. Here, how the TLS connection is formed, right? It is sending this hello message. Hello message is carried by ePOL to till this switch, and from switch it is taken by the radius message. Hello is reached here, and all the content parameter are exactly same whatever we have read, right? Version, random number, right? And then what are the cipher suits supported, and then it is going to say hello. This hello is also encapsulated in radius from ISE to switch, from switch to ISE in ePOL. Once it is reaches there, right? And then basically server sends what? You all know, certificate. And that is where you need to do this configuration on this server. You have to say this to the server that Mr. Server, when you are trying to use EPEEP method, you have to verify your authenticity to the client. And if you want to verify your authenticity to the client, use your certificate. Which certificate? Don't worry about it. I am going to give you. I have a certificate authority. You come to me, I can assign you a certificate, you install the certificate and use that certificate in making TLS connection when somebody wants. So when somebody wants to do EPEEP with you, believe me, the time we spend in those 6 or 7 classes is really important. Nobody can understand if you have that kind of background. And that is why people have hard time to understand all these things, right? So once the certificate reaches here, right, Rahul is going to verify it. How it is going to verify it? And because Mr. Rahul is going to have root certificate of what? Certificate authority, right? Because certificate authority has signed it with private key. And if you want to verify it, you need its public key, and that is what contains the root certificate, right? How it is going to come here? And that is where you need to create this complete infrastructure. You need to tell to ISE, and that is where configuration is required. And that is why people like you and me are required. You need to configure this server-side certificate on the ISE. You need to configure the root certificate on the machine itself so that it can verify. Once it verifies it, Rahul is going to get the public key. And through the public key, it can share the secret key, just like the TLS work. And after that, all the communication can happen in the encrypted format, right? Now, one thing is done. In EPEEP, Mr. Client has authenticated the server that yes, it is talking to the right guy, right? Because it might be the case, instead of ISE, you have been fooled and somebody else is sending messages to you, right? So maybe we will be able to authenticate with this guy, but the problem is you are talking to somebody else. That is why you need to verify the identity of the server. Now, the other thing, the most important thing, whatever we are doing here is not, we want to authenticate the client because he wants to join our network, right? But on the contrary, what we are doing, we are making sure that the client understand that, yes, he's talking to the real server. And that is where EPEEP said that once the TLS is formed, TLS tunnel is formed, the data which you are going to send over this tunnel or over this connection is going to be highly encrypted. with the use of secret keys, right? Now we can send my username and password. So by the way, I can define that this client should be authenticated using a Microsoft protocol, which is known as MS CHAP version 2, Microsoft Challenge Handshake Authentication Protocol. Interesting, right? And in this protocol, we have username and password based authentication, but we never send username and password. We send hash of username and password. Maybe that is dollar and exclamation mark. Interesting. Now I can send this hash value from here to here. And of course, how this hash value is going to flow? Equal and radius, equal and radius, as simple as that, right? This value will be reaching here, dollar and exclamation mark. And of course, this identity services engine knows the Rahul's username and password name from where? Of course, from the Active Directory, and it can run the same hash value there. And if this hash value match, server now has authenticated the client also, right? Really, really interesting. But this is one way. And after so many messages, that is why I haven't decided how many messages are going to be exchanged. Maybe hello message, certificate message, and then username, password, and so many things. Maybe there are 20 messages to and fro. But once we have verified that these are my hashes, right? Hashes are matched. I am absolutely sure client has verified the server, server has verified the client. That is what we wanted to do. Specifically, we want to do the client-side authentication, and that is done by username and password, but with the very secure method, right? Absolutely secure method, right? Now, once this hash is matched, ISE knows, or Identity Services Engine knows, that it has verified the client, and that is why it is going to say access accept. This is the radius message, which is equivalent to that server is saying authentication is done, authentication has been successful. And once this message reaches to this switch is going to open it. It is going to send the EAP message. It is going to convert this message into the EAP message, or maybe the EAP message was coming into the radius message was access accept. It is going to open it. It is going to send the EAP success message right here, so that client understand we are good. And then basically once this connection is done, then maybe this client gets log off, it can send the EAP log off message. So this session is tear down. By the way, one important thing here, Mr. Daniel, I can see that there are a lot of questions, but believe me, I will be answering them once I complete the topic. Okay. So the whole sole point here is, which is very important, there is no doubt about it that the 0/1 port now will be open, right? Because I have identified the client. I have absolutely identified the client here, right? So it's my responsibility to open it, but how much I want to open it, right? And that is also I can define in ISE in authorization policy, because it is as good as that we have a big building with so many rooms, right? And I have said that I have authenticated this guy. Now this guy is inside the room, so inside this building, but every room is locked. Where exactly it has the permission to go? How authorized he is? And that is also, that thing also I can send in this access accept message, which was sent by this server, the access accept message. And inside this message, inside this radius message, it can guide, because this message will be reaching to switch. It can say that 0/1 port should have this VLAN, because Mr. Rahul is from the sales VLAN. The sales VLAN number is 10. This is my attribute. This is my value. So we can send attribute value pairs so that I can define how much authorized Mr. Rahul is on my network, right? On what server he can go and log in. Interesting. So radius protocol is much more than passing just the EAP messages. It is just passing some attribute value pair also. On the basis of that, this switch decide what is the authorization of this port, what is the authorization of person who is connected on this port. And by the way, you have to configure this. You have to configure the authentication method. Right now, I have explained you EPIP. You can say EPTLS also. You can define EPTTLS also, or maybe any other 2025 methods. You have to configure it. You have to configure authorization also there. Once the guy is authenticated, what authorization, how much authorized he will be on my network. As simple as that.